Hello! In most of my videos you will find me at my desk, sitting behind my laptop explaining about the Desk Proto software. Not in this video. This is my small workshop, and here on the right you see the ISO 4030 machine that's used in many tutorial videos from Germany, no longer available but it's still working. And here is the newer machine, the SainSmart Genmitsu 4040 machine. And the next video will be done using this machine, using the rotation axis on this machine. And as a number of steps were needed to get the rotary module running on the machine, I decided to make a separate tutorial video about that, because that is not really a Desk Proto tutorial. So this tutorial will be about setting up a rotary axis on the Genmitsu machine. Obviously the first step was to read the user manual that SainSmart provides with the rotary module. Still, I was very happy that I could also use this tutorial written by Graham Bland. It gives much more detailed instructions. Graham published it on Facebook in the SainSmart Genmitsu CNC user group, and we are very happy that he allowed us to share this on the Desk Proto website as well. You can find it on the website via support, then tips and tricks for certain machines, the SainSmart machine. And before mounting the rotary unit, I checked the dip switches. I left them on the factory default, so off, on, which means the subdivision is 32 and the DC power is from 3 to 5 volts. This worked fine for me. And well, here the rotary module, which can be installed on the working table using 8 screws. Graham advises to first surface the machine bed or the spoil board, so machine the complete surface to make sure that its Z value is on the same, that the Z value, the height is the same on any location. I need to confess that I skipped that step, trusting the original machine table to be accurate enough. Graham's next advice may absolutely not be ignored, as you can see here. When the Z-axis unit is mounted in its lowest position, you can mount it in 2 positions, it will hit the rotary module. So it's absolutely important that you mount the unit on its high position, as you can see here. Then the complete bridge and the Z-axis can move over the rotary unit. Okay, as said, you secure the model, you tighten the model using 8 screws. When you do that, you will find that the alignment with the x-axis is not automatic, so rotation of the unit is possible. So you need to make sure that the module is correctly aligned with the x-axis. I did so using a cutter and a cigarette paper to check the Y position, both on the left and the right. First, I measured on the left side, so the far off side on this photo, with one of the screws tightened. I measured at a position next to that screw. And next I measured on the right side, so in the front on this photo, giving rotating unit to give it exactly the same Y value. SainSmart advises to use the rail in the center for this measurement. I found this easier. Note that as the Z-axis unit is in its highest position, you need to use a very long cutter, otherwise you can't reach the base plate of the module. Next step was to connect the cable to both the rotary module and the controller, which was not really easy. My fingers are just a bit too thick to do that, but I succeeded nevertheless. For the software, I decided to start using the Candle software, simply because that is the software that I also use for 3-axis jobs on this same machine. Candle's user interface does not provide any options for the 4th axis. you can't move, you can't rotate the block using a button on the candle screen. But okay, you can set the orientation for A is 0. You can set the orientation by entering G92 A0 in candle. So the wireless offline controller is not absolutely required to use this rotation axis unit. It might make it easier, but it's not required. In candle, I then needed to enter a series of settings for the 4th axis, and these settings have been kindly provided by Graham Blend. I just copied them. Here they are. $1 is to keep the stepper motor locked in all cases, otherwise the A position will easily get lost. 103 is the number of A steps to move the rotation axis 1 degree. Maximum feed rate, acceleration, and the maximum value. So this says that the axis may allow 1,000 rotations in the same direction. And after that I did 2 simple tests to check the working of the module. The first, the rotation distance. So the test was simply enter A36 or first G92 A0 to set the A0 position, and then simply enter A360. So that will cause the rotation axis to do a full rotation, and as you can see, it is indeed a full rotation. It's not really accurate. For an accurate measurement you should write a line on the rotation axis and on the other unit, and then do say 1,000 rotations and then see if it's still the same, but I just checked, made this rough check. The next test was about the rotation direction. So when you rotate the axis in a positive direction, the positive A value is the rotation of the actual machine, the same as the rotation in your CAM software. And it may be a bit confusing because when the toolpath moves, rotates so to the left, then in fact this means the block rotates in the other direction. So that's, well, how have I tested this? I used the Desproto software and I created some toolpath from 0 to 90 degrees and have sent these to the machine. As you can see here, the movement of the machine is correct, so this test was okay. I need to mention that I used the SainSmart post-processor in Desproto, as in the post-processor the rotation direction will be set. Well, both tests were okay, so I could proceed and prepare for my first rotary project. Well, the next step was setting the 0 point, and note that for rotary machining an accurate 0 point is far more important than for 3-axis jobs. I will explain why later. First, the y-axis 0, and as you can see here I touched the rail on the rotary module with a cutter, and then I corrected that value. It was a 6mm diameter cutter, and so when touching I was 10mm for half of the rail and 3mm for half of the cutter, so 13mm off center. So I touched this, set y is 0, then moved 13mm and again set y is 0, and that was the accurate y is 0 with the tip of the cutter exactly on the rotation axis unit. The next was the x is 0, and I set that to make sure that there was some distance between the jaws of the chuck and the collet, to make sure that these would never hit. The third one was the z is 0, and here I used the top of the rotary module unit. I touched that one, and then I moved the cutter back a bit, lowered it 24 millimeters, and set z is 0 there. And with these 3 settings, x, y, z, I have my the tip of the cutter exactly on the rotation axis. Keep in mind that before starting to machine, you need to first move the cutter back to Y is 0, as not all rotary toolpath files contain a Y is 0 command. And also keep in mind that A is 0 is not saved when you switch the machine off. So when you set X, Y and Z 0 after first doing a homing position for the machine, then the Candle software will remember that 0 point. However, A is 0 will not be remembered. So simply keep your machine on and Candle on until you finished your rotary project. Okay, my first rotary project, a small block of wood. I drilled a hole in the center of one side for the till stock, and I could mount the block in the machine. This first project is a simple calibration project. I created a cylinder of diameter 26 millimeters. I loaded that in Desproto and I created toolpath, roughing and finishing, and I'll send that to the machine. The idea is to later measure the diameter of the actual cylinder to check the workpiece 0 point. So here is the roughing. Starts and continues, and after roughing it continues with the finishing operation, and when that is ready I can use my caliper to measure the diameter of the cylinder, and if it's too thick I need to, or too thin, I need to adjust the Z is 0 value. And I can check the Y is 0 by touching this cylinder on both sides, on the Y plus and the Y minus side, and both values need to have the same, both distances need to be the same. I promised to explain why for rotary machining it is so important to accurately set the workpiece 0 point. For normal 3-axis machining, the 0 point in fact does not influence the result. Well, assuming of course that your block of material is large enough. That is however different when you use the 4th axis. This image shows what happens when the Z is 0 has been set a bit above the rotation axis line, so a bit too high. The blue line shows the CAD geometry, and as you can see the resulting part in brown will be too large, which may or may not be a problem as the part still will look okay. However, in other situations an error will result that is clearly visible. This will happen for instance when the cutter needs to travel below the rotation axis, as then, as you can see, the side of the cutter can machine the same area that at a different angle or at a different A value has been done by the tip. In this drawing the same Z is 0 error is present. The Y is 0 has been set accurately, so here the side of the cutter will machine what should be the same surface at a different location, and as a result a clearly visible ridge will be present over the part. A similar error will result when you use indexed machining, so when you use XYZ 3-axis toolpath from several sides of the same part. Okay, so far about setting the 0 point. One final tip in this video concerns the feed rate. In my first test, the actual feed rate on the machine was very low. So I checked if Gobble supports the inverse time feed rate, which is the ideal method for rotary feed rates. And indeed it does. So in Desproto I enabled this advanced option, you see, inverse time feed rate. The help file, by the way, will explain how this works. And the next NC file that I saved was done using the correct feed rate as set in Desproto. The next video will be about machining this lion table leg on the SainSmart rotary axis. Of course, using the CAM software that excels in rotary axis CAM support, which is DeskProto. Thank you for watching. I hope we will see you back in the next video.